Hello all, in this video I am going to solve question number 32A and B from CBSE class 10 standard math 2026 board paper. The question paper code is 30/5/3. The question 32A says D is the midpoint of the side BC of the triangle ABC. CE and BF intersect at a point O and this point O is on AD. AD is produced to G such that OD is equal to DG. Prove that OBGC is a parallelogram. So let's observe this quadrilateral OBGC. In OBGC, BC and OG are diagonals. Here D is the midpoint of BC and this D is also the midpoint of OG. That is, these two diagonals are intersecting at the same point D. The diagonal BC cuts the diagonal OG into two equal parts. Same way, the diagonal OG cuts the diagonal BC into two equal parts. Therefore, this shape is a parallelogram because diagonals bisecting each other is a property of parallelogram. Hence, the first statement is proved. The second subdivision says we have to prove that EF is parallel to BC. That is, this line segment is parallel to this line segment. In part 1, we proved that BG is parallel to OC. Now, this line segment OE is a part of this OC, which means this OE is also parallel to BG. Now, let's observe this triangle AGB. In triangle AGB, the line segment OE is parallel to BG. So by BPT, we can say that AE upon EB is equal to AO upon OG. Let this be equation 1. Similarly, GC is parallel to OB. The line segment OF is a part of this OB. Therefore, GC is parallel to OF also. Now let's observe this triangle AGC. OF is parallel to GC, which means by BPT, AF upon FC is equal to AO upon OG. Let's name this as equation 2. Comparing both the equations, AO upon OG is common in both. Therefore, AE upon EB is equal to AF upon FC. That is, AE upon EB is equal to AF upon FC, which means that EF is dividing the sides AB and AC in the same ratio. By converse BPT, EF becomes parallel to BC. Hence, this second statement is also proved. The third statement says, prove that triangle AEF is similar to triangle ABC. Now, let's look at the triangles AEF and ABC. Angle A is common in both, and angle AEF is equal to angle ABC because they are the corresponding angles as EF is parallel to BC. Therefore, by AA similarity, triangle AEF is similar to triangle ABC. Hence, proved. The question 32b says, through the midpoint Q of side CD of a parallelogram ABCD, the line AR is drawn which intersects BD at P and produced BC at R. Prove that. Q is the midpoint of the side CD. AR is a line segment drawn through this point Q. AR intersects BD at point P. BC is produced to R, which meets AR at R. The first thing that we have to prove is AQ is equal to QR, that is, this portion is equal to this portion. For that, let us consider the triangles QCR and triangle ADQ. If we prove the congruency of these two triangles, then we can say AQ is equal to QR by CPCT. In triangle ADQ and triangle RCQ, angle ADC is equal to angle RCQ since they are the alternate interior angles. Next one is DQ is equal to CQ since Q is the midpoint of DC. Then the third one is angle DQA is equal to angle CQR. The reason being they both are vertically opposite. Therefore, by ASA congruency, triangle ADQ is congruent to triangle RCQ. which implies that the side AQ is equal to side QR by CPCT. Hence, the first statement is proved. The next subdivision is prove that AP is equal to 2 times PQ. For that, let's take these two triangles. In case we prove the similarity of these two triangles, then we can prove this statement. In triangle APB and triangle QPD, angle APB is equal to angle QPD. That is, these two angles, they are vertically opposite. The next equality is angle APB is equal to angle QDP. These two are alternate interior angles since the side AB is parallel to CD and BD acts as a transversal. Therefore, by AA similarity, triangle APB is similar to triangle QPD, which implies that the ratio of the sides are proportional. AP upon PQ is equal to AB upon QD. We need AP and PQ, so let's retain these two and replace AB with CD and let the QD also remain. AP upon PQ is equal to CD is 2 times QD upon QD. QD gets cancelled, so AP upon PQ is 2 upon 1, which means AP is equal to 2 times PQ. Hence, the statement is proved. The third statement to be proved is PR is equal to 2 times AP. That is, this distance PR can be written as the sum of PQ and QR. Let's retain PR as such. PR is equal to PQ plus, instead of QR, we can write AQ. So PR is PQ plus AQ is AP plus PQ, which is 2 times PQ plus AP. 2 times PQ can be replaced with AP. So PR is equal to AP plus AP, which is nothing but 2 times AP. So this is the statement that has to be proved and hence proved. If you found this video helpful, don't forget to like, share and subscribe to my channel Math with Meenakshi for more smart learning videos.